So we are going to add to the log and exponential functions notes. And if you remember in the last class, we were talking about exponential growth and decay. So for example, if this is the last problem we did in our last class, a car is purchased for $21,000, but depreciates at 9% per year. And we figured out its worth after 10 years. So when things decay, we take 1 minus the percentage. And then we just plug that into our calculator. When things grow, like in this case, we had a town of population of 18,000 was growing at 3%, we do 1 plus our percentage. Okay, and we get 1.03. And then this 18,000, of course, is our initial amount. And so we just plug that into the calculator. So we're going to do similar problems today. However, the difference is these are going to be more specific, that we're talking about how long it takes for something to be half of its original or for it to be double its original. So people are kind of fascinated with, half-life, or how long it takes something for it to be half as much, or how long it takes your money to double, for example. So all right, this guys, you probably are going to want to write down because I'm going to give you a couple of formulas, okay? So the first one is the halving formula for half-life. So it's really just a version of our other formula. So while you're writing that, I'm going to scroll back up here. Remember this thing, that exponential formula, y equals ab to the x? It's the same thing, kind of, but we're now, that b value, because we're taking half of something. Our halving formula is y equals a, and now our value inside there is 1/2, and we have t over h. And a lot of those things stand for the same stuff as before. So a is still the initial amount. Y is still the final amount. I should have said that first probably, but y is the final amount. T is still time. But there is a difference, that h is the halving time. It's the amount of time it takes. It's like the half-life of something. The amount of time it takes for something to be half of the original. All right, so for example, let's say a new car is $18,000. I think that's how much it was in our last example. So a new car is $18,000 and depreciates to half its value every 4 years. So a new car is $18,000 and depreciates to half its value every 4 years. Now, before we move on, I want to make sure that we're clear about something. That doesn't mean that in 8 years, it's worth 0. Okay, because when you take, that means if it's $18,000 to start off with, in 4 years, it's worth $9,000. But then 4 years after that, it's going to be half of the $9,000. It would be worth $4,500. Okay, and then 4 years after that, it would be half of the 4,500. So it's depreciating to half of its value every 4 years. And a lot of things, do depreciate that way, even objects like cars, because they depreciate a lot at the beginning and then a little bit as they move on. All right, so we have a new car is $18,000 and depreciates to half its value every 4 years. What is its value after 17 years?
Mr. O'Connor, so I'm guessing you can't do like 50%,
Yeah.
as the percent. Okay.
Um, the reason you can't, you're kind of already doing that. The formula does it for you. If you do 1 minus 50%, you'll get 0.5, which is 1/2. So the problem would be, though, the exponent if you use that old formula. So that's why we have a new formula for the halving. So we want to know our final amounts. Our initial amount is 18,000. This is a half problem or a half-life problem. Our time is 17 years, and the half-life is 4 years, or the amount of time it takes to be half of its value is 4. All right, so now that might take a little calculator skill. So why don't we make sure that we practice using our calculator here? So I will do this first one on the handheld, and then the next one I'll do on the app. You guys should all be doing this here. All right, so we've got what, 18,000. Oops, sorry, got to get rid of this. Get to my calculate screen. Here we go. 18,000 parenthesis 1/2. Now my exponent is also going to be a fraction. It's 17 over 4. Now, if I hit enter, look at how ugly that number is, because remember, we want to do an approximation. So I'm going to do control enter on the handheld. On the other one, you have to click and hold the enter button, but we should all get $946.01 as we round that up. All right, so it's worth $946. And so, and that number hopefully makes a little bit of sense. I mean, if you think about it, started at 18,000. After 4 years, it was 9,000. 4 more years, it was 4,500. That's 8 years. 4 more years, it's 2,250. And so it's going to be less than half of that. So the answer does make sense. All right, let's do another one. Any questions before I go on to the next one? All right, well, let's say we have an isotope decreases to half its mass every 28 hours. Okay, so an isotope decreases to half its mass every 28 hours. If the initial mass is 40 grams, how much remains after 11 hours? So we have an isotope that decreases to half its mass every 28 hours. That means its half-life is 28 hours. If the initial mass is 40 grams, how much will remain after 11 hours? So again, we're starting with 40 grams, and in 28 hours, it's going to be at 20 grams. So we're only talking about 11 hours from now. So our answer should be larger than 20. So we have that kind of going for us in terms of a ballpark. But we want to know our final amount with an initial amount of 40. We're using the half-life formula. Our time is 11. And our half-life is 28. So we had 40. We have 1/2. To the 11/28 power. Remember, I have to click Control and hold that to get my approximation. And it is more than 20. It's, 30.5 rounded to the nearest tenth. So how much remains after 11 hours? About 30.5 grams.
Would it be wrong if we didn't round it?
No, it will ask specifically in your homework. It'll say like round to the nearest tenth or round to the nearest hundredth. And if it doesn't, then no, it would not be wrong. You can put whatever you want.
Okay, thanks.
All right, so that's if you're taking half of something, okay? There is also, if we are going the other way, if things are doubling. So there is a doubling formula, which is very similar. So the doubling formula is Y is our final amount, A is our initial amount, but now our B value is 2 because it's doubling, it's 2 times that. Which, getting back to the other, is like 1 plus 100% or 1 plus 1. And our T is still time. And we're going to put that over D, where D is the doubling time. All right, so let's say you have, let's say, $7,300 in an account. That doubles every 14 years. So you have $7,300 in an account that doubles every 14 years. How much is in the accounts in 25 years? So we have $7,300. You have $77,300 in an account that doubles every 14 years. How much is in the account in 25 years? Let's do some mental math, some round numbers. We have $7,300. In 14 years, that's going to be $14,600. And then we have $14,600. And then in 14 more years, that's going to be like this number doubled, or $29,200. But that would be after 28 years, because that would be like doubling and then 14 years and then doubling again. So let's use our doubling formula here to find the final amount. We want to know our final amount with our initial amount of 7,300. We have our doubling amount, which is 2. We're talking 25 years, and our doubling time is 14 years. So I'll do the handheld first. So we have 7,300 and times 2 to the, whoops. All right, there we go. All right, here we go. 7,300 times 2 to the 25 divided by 14. And I'm going to hit Control Enter. And so now we have $25,169.60. All right, I'm going to do one more. Are there any questions yet on those? All right, let's do one last example. So 2,200 bacteria in a Petri dish double every 10 hours. So 2,200 bacteria are in a little Petri dish and it doubles every 10 hours. How many bacteria are in the dish in 40 hours? All right, so we have 2,200 bacteria in a Petri dish, doubles every 10 hours, and we want to know how many are in the dish in 40 hours. So we want to know our final amount, which is Y. Our initial amount is 2,200. We're using the doubling formula, of course. Our time is 40, and our doubling time is 10. So I'll use the app this time. So we have an initial amount of 2,200 times 2 to the 40 divided by 10. Click and hold the enter. And we have 35,200. And you know, that one, we actually, if you wouldn't even have to use the formula if you think about that, because these were nice numbers. But just to show you a check, you know, if it's doubling every 10 hours, we started with 2,200, right? And it's doubling every 10 hours. So after 10 hours, it's going to be 4,400. And then after 10 hours, that's going to double to 8,800. And then after 10 hours, that would be 17,600. And then after 10 more hours, that's going to double. And that would be 35,200. That was after 40 hours. Okay, so I kind of give you nice numbers for that just to show that, you know, you can use the formula in that case, even with the nice numbers. All right, you guys have any questions for me before I move on? Okay.